Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of concavity.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x to the fourth power plus x to the third minus 3x squared plus 1. And we want to find the x-coordinates for all the points of inflection, discontinuities, and the intervals where the function is concave up and concave down. Well, first thing I noticed that this is just a basic polynomial function, meaning it's continuous everywhere. So right off the bat here, I can say no discontinuities exist. Pretty straightforward. Now, to find where our point of inflection and we're concave up and concave down, we need to find the second derivative. So to do that, I take my function, I'm going to find the first derivative first. Power rule, 4 comes down, x to the third power, pretty easy. 3 comes down, x squared, not too bad, and 2 times 3 is a 6. So we have minus 6x here. And that's it, derivative 1 is 0. From there, I need to find the second derivative, f double prime of x. And so, again, power rule, 3 comes down, 3 times 4 is 12. X squared plus 2 times 3 is 6x, and then we have minus a 6 here. Now to find my point of inflection, and where we're concave up, concave down, I need to take a second derivative and set it equal to 0 and solve for x. So 12x squared plus 6x minus 6, I set equal to 0, and now I'm solving. Now, right off the bat, I'm just going to pull out a 6 here from everything. I found it a little easier. And I'm left with a 2x squared plus 1x minus 1 equals 0. Divide both sides by 6. We don't really kind of eliminates that, right? We have 2x squared plus x minus 1 equals 0. And with factoring, I find that a little easier. This factors to be a 2x minus 1 times an x plus 1. And then from there, we set each parenthesis equal to 0 and solve. 2x minus 1 equals 0, and x plus 1 equals 0. Here, subtract 1 on both sides. 2x equals 1, and x equals a 1/2. Subtract 1 on both sides, and x equals a negative 1 here. So we have 2 points here. We need to make our little chart for the second derivative test. So, make my chart right here, within the bounds. Okay. And from there, I start with the negative 1 and 1/2. In our second derivative test here, we need to plug in values into our second derivative and see if they're positive or negative that are within these intervals. So I picked negative 2, so I said f double prime of negative 2, and that came out to be a positive 30. So I got my spot right, yeah. I don't care what the number is, I just care that it's positive, and that means we're concave up here. Between negative 1 and 1/2, I picked 0, so I said f double prime is 0, plugged it into my second derivative, and I got a negative 6 here. That means we're negative, that's all I care about it, and it's concave down. Lastly, we have 1/2. Well, I'll pick a value just bigger than 1/2. I picked f double prime of 1, and that came out to be, plugged into my second derivative, a 12. It's positive 12, concave up. And so now we have everything we need. We have our point of inflections where we change concavity from negative 1, or at negative 1 and at 1/2. So we'd say our inflection point is at x equals negative 1 and a positive 1/2. We are concave up. All right, the intervals where we're concave up are from negative infinity to a negative 1, and from a 1/2 to a positive infinity, and we're concave down from the interval from negative 1 to a positive 1/2. So just review our answers here. No discontinuities exist. Inflection point is from x equals, or at x equals negative 1 and a 1/2. Concave up from negative infinity to negative 1, and 1/2 to positive infinity, and concave down from negative 1 to 1/2. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.